Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today, we're diving into Language Intelligence Unleashed, examining 45 breakthrough papers in computational linguistics from July 22, 2025. Picture this: researchers worldwide have unveiled AI systems that reason like humans, detect their own contradictions, and navigate complex moral dilemmas. These aren't just laboratory curiosities, but real-world applications making measurable impact across healthcare, science, and multilingual domains. Today's journey takes us through 6 dominant research themes shaping computational linguistics. We'll explore real-world breakthroughs in healthcare AI deployment, where systems are reducing medical errors by 16%. We'll examine technical innovations in efficiency and reasoning capabilities that are democratizing access to advanced AI. Most importantly, we'll spotlight 3 seminal papers that represent paradigm shifts in how machines understand and generate human language, pointing toward exciting future directions for human-AI collaboration. Computational linguistics stands as the bridge between minds and machines, representing the intersection where human language meets artificial intelligence. This field encompasses everything from how computers process and understand text to how they generate coherent, contextually appropriate responses. Think of it as translating between the messy, ambiguous, culturally rich world of human communication and the precise, logical realm of computer processing. Every time you ask Siri a question, translate text on your phone, or interact with a customer service chatbot, you're experiencing computational linguistics research. The field has evolved dramatically, moving from handcrafted rules and extensive feature engineering to neural networks trained on vast text corpora, enabling unprecedented levels of language understanding and generation. The first major theme centers on real-world deployment revolution, where researchers are moving beyond academic benchmarks to tackle genuine societal challenges. The most striking example comes from AI-based clinical decision support systems deployed in Kenyan healthcare clinics, where AI assistants reduce diagnostic errors by 16% and treatment errors by 13%. This represents a fundamental shift from laboratory experiments to life-saving applications. The significance lies not just in the error reduction, but in demonstrating that AI systems can enhance rather than replace human expertise when properly designed and implemented. Healthcare professionals unanimously reported that these systems improved care quality, with 75% describing the effect as substantial. The second theme focuses on efficiency and architectural innovation, addressing the critical need to make powerful models more accessible. As language models grow larger and more capable, researchers are developing ingenious methods to maintain effectiveness while reducing computational requirements. This includes groundbreaking work on binary representations of natural language processing embeddings, where continuous embeddings are compressed into binary codes without losing their effectiveness. Similarly, character-level multi-head decoding architectures decouple input and output vocabularies, achieving competitive performance while significantly reducing computational overhead. These innovations are democratizing access to advanced AI capabilities, making sophisticated language understanding available in resource-constrained environments. The third theme addresses trustworthiness and advanced reasoning, reflecting growing recognition that powerful language models require equally sophisticated evaluation methods. Multiple papers tackle the critical question of how we can better assess model limitations and biases while building systems capable of sustained, complex reasoning. This includes sophisticated approaches to detecting nationality bias through name-based benchmarks and developing external validation tools to improve AI-generated annotations. Perhaps most exciting are subconscious threads enabling long-horizon reasoning and comprehensive datasets for scientific reasoning spanning 7 disciplines. These advances point toward AI systems that can engage in the kind of sustained, logical thinking that characterizes human intelligence. 3 additional themes are reshaping the field's landscape. Domain-specific applications and multilingual capabilities demonstrate how general-purpose language models can be adapted for specialized domains and languages, moving beyond English-centric approaches toward truly inclusive systems. We see this in synthetic data improving agricultural question answering across multiple languages and systems designed for multilingual question answering over knowledge graphs. Multimodal understanding represents another frontier, where AI systems process multiple content types simultaneously while adopting specific personas and maintaining consistency across interactions. These developments point toward universal AI systems that can serve diverse global populations effectively while handling the full richness of human communication across different cultures, languages, and modalities. Several breakthrough findings emerge from this research collection that will reshape AI capabilities. The most significant comes from healthcare, where AI-based clinical decision support systems demonstrated measurable error reduction in real-world settings. This study, conducted with Penda Health clinics in Nairobi, Kenya, represents one of the first large-scale demonstrations of AI improving clinical outcomes in high-stakes environments. The findings suggest that introducing AI assistance could prevent diagnostic errors in 22,000 visits and treatment errors in 29,000 visits annually at just one clinic network. Another breakthrough involves multimodal language models exhibiting systematic self-contradiction, where models generate images they then evaluate as misaligned with input prompts. Remarkably, this self-contradiction stems from weak generation rather than poor understanding, creating opportunities for self-improvement without external supervision. The research reveals several methodological approaches becoming standard practice in computational linguistics. Reinforcement learning from human feedback appears as a central methodology across multiple papers, where models learn not just to produce correct answers but to recognize the boundaries of their knowledge. This approach aligns model behavior with human preferences and values, making systems more trustworthy and reliable. Multi-agent architectures have emerged for complex reasoning tasks, employing multiple AI agents with specialized roles such as planning, entity linking, or knowledge retrieval. Synthetic data generation has become crucial for addressing data scarcity in specialized domains, creating large-scale, controlled datasets where real data is expensive to obtain. Feature-specific optimization recognizes that different features may have different statistical properties, while transfer learning and domain adaptation continue evolving with increasing sophistication. Our first spotlight paper by Korom and colleagues represents groundbreaking work on AI-based clinical decision support for primary care. Rather than conducting controlled laboratory studies, these researchers partnered with Penda Health, a network of primary care clinics in Nairobi, Kenya, to implement and evaluate their AI consult system in actual clinical practice. The methodology employed impressive scale and rigor, conducting a quality improvement study comparing outcomes for 39,849 patient visits across 15 clinics. The AI consult system was designed as a safety net integrating into existing clinical workflows, activating only when needed while preserving clinician autonomy. Independent physicians rated patient visits to identify clinical errors, providing objective measures that reflect actual clinical impact rather than just performance on standardized tests. The second seminal paper by Fan and colleagues addresses MegaScience, tackling one of the most significant gaps in current AI development, the lack of high-quality, large-scale datasets for scientific reasoning. Their work represents a comprehensive effort to advance AI capabilities in scientific domains, crucial for developing systems that can assist in scientific research and discovery. They introduce textbook reasoning, an open dataset featuring truthful reference answers extracted from 12,000 university-level scientific textbooks, comprising 650,000 reasoning questions spanning 7 scientific disciplines with unprecedented scale and breadth. Building on this foundation, they developed MegaScience, a large-scale mixture of high-quality open-source datasets totaling 1.25 million instances. The experimental results demonstrate significant improvements across multiple model families, with MegaScience exhibiting greater effectiveness for larger and stronger models. The third seminal paper by Luo and colleagues on Thread Inference Models represents a breakthrough in overcoming context limitations that have long constrained language model reasoning. Their work tackles one of the most fundamental limitations in current language model architectures, the context window constraint that prevents models from maintaining information across extended reasoning sessions. Their Thread Inference Model introduces a revolutionary approach enabling virtually unlimited working memory through subconscious threads that persist across multiple inference calls. The system maintains a persistent memory state that can be selectively updated and accessed throughout extended reasoning sessions, allowing models to engage in multi-hop reasoning and tool use without being constrained by context limitations. The technical implementation involves sophisticated memory management that can manipulate up to 90% of the key-value cache and GPU memory while maintaining high inference throughput. Looking toward future horizons, several exciting frontiers emerge from this research. First, we're likely to see increased focus on real-world deployment and practical applications, moving beyond academic benchmarks toward systems that demonstrably improve human outcomes in critical domains like healthcare, education, and scientific research. Second, The field is developing more sophisticated evaluation frameworks that assess not just performance but also reliability, fairness, and alignment with human values. Third, architectural innovations focused on efficiency and scalability will accelerate as language models are deployed at increasingly large scales. Fourth, the integration of external knowledge and tools with language models represents a shift toward more modular and extensible AI architectures. Finally, the emphasis on multimodal understanding and cross-cultural reasoning suggests future language models will be more inclusive and capable of handling the full richness of human communication across different cultures, languages, and modalities. These developments showcase the remarkable maturity of computational linguistics as it transitions from laboratory curiosities to practical tools that measurably improve human outcomes. The growing emphasis on evaluation, fairness, and reliability reflects a field taking seriously its responsibility to develop AI systems that are not just capable but also trustworthy and beneficial to society. The methodological innovations point toward a future where AI systems are more efficient, more capable, and more accessible. The interdisciplinary nature of this research, spanning computer science, linguistics, psychology, and domain-specific applications, demonstrates that the future of AI will be built through collaboration across disciplines and cultures. Content synthesized using GPT and Claude Sonnet 4 models, with TTS synthesis powered by Amazon Voice Technology, image generation by Google Systems, and human expert review for accuracy and coherence. These developments represent just a single day's worth of research in a rapidly evolving field, yet they provide a glimpse into a future where AI systems are more helpful, reliable, and aligned with human values. I encourage you to explore these papers yourself and consider how these advances might impact your work and life. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv-preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv-preprintserver.org.